Yeah, so this is the function that we'll be dealing with, the transfer function, and this is the question. Okay? So we move to the next page. And this is 22. So I'm just writing down this denominator polynomial for convenience. So let us form the array. So we have 1, 12, 22, sorry, 1, 12, 39, 48, 20. Then 1, 22, 59, 38, 0. And so I'll be getting minus 10. This is what you will be getting after solving. So already we have positive, positive, negative here. And this is going to be 1, 3, 2. So already we have one sign change, two sign changes. And this will be
Sir,
yes.
so that sign change, like only if the first component of the third row, if it undergoes a sign change, then we can consider it as a sign change, or both the first and second should change. Like in every
What?
case we have discussed before, the first and the second term in the third row have changed sign.
No, here, see here. What are the number of sign changes? The number of sign changes so far we have encountered.
Yes, sir. Like we are considering the sign of the first, I mean the first part of the Every
Yeah,
row, right? Like the first column of every row.
not every row. Yeah, first column of every row, yes. Only the first column. So no sign change here, no sign change here, one sign change and another. Because it's positive to negative, one sign change, negative to positive is another sign change. So there are two sign changes. So normally you will have a situation of one sign change if the sign change occurs in your bottommost row.
Sir, suppose in the third row for S6, had it been plus 10 and minus 20.
Plus 10 and minus 20, then it would be, I mean, like up to here there would be one sign change. Then that is positive, negative. Now here it would be again positive. So if you are saying that it is plus 10, then this would have been positive, this would have been negative, and this would have been positive. So again two sign changes. So if you have a row in between having a sign change, then I mean like you are going to see two sign changes. But if it is, I mean like at the bottommost row, only then there is a possibility that there is a single sign change. That is a positive, 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 positive all through, because you see, you will obviously, when you have a polynomial, you will convert it into something with, when are you going to use route? You are going to use route when you are forced to, that is, you see that all your polynomial has same signs for all coefficients. In that case, you won't leave them as negative. You will factor out minus 1 and make all the coefficients positive and then apply route. If in your polynomial straight away you see negative coefficients or negative positive coefficients, then you already know that this is a gone case. You have to take remedial measures even before you do route. You can do route for further analysis, but normally a strict candidate for route is when you have all coefficients negative or all coefficients positive. In the former case, you will convert it into all coefficients positive by multiplying or dividing by minus 1. So if that happens, then that means your first row is going to be positive. So the only possibility of a single sign change will be when your last row shows a sign change. So in that case, you will have only one sign change. Otherwise, you normally don't have a single sign change. It will always be two, at least two. So you have, coming back to what I was doing, I have S cube. There it will be 2. Sorry, 4, 6, and these will be all.
Sir, this you're writing directly after the differentiation, is it? Or
No, I'm not doing a differentiation. Not yet.
if
This will
S
come
cube
out.
was supposed to be all zeros, right?
Yeah, it is. Which one?
S cube row.
Yeah.
If we just use the normal.
Oh, yeah. Sorry. Yes, I jumped. Yeah, this will be coming out as zeros. 1, 3, 1, 3 is already 0. So this will be coming out as zeros. So this is my all 0 thing. So even before all 0 thing, what have I seen here? There are positive to negative, negative to positive, two sign changes already there. So it is here that we are going to see a new polynomial. And that polynomial will be formed by looking at the row above. So I'll have PS
Sir, 3s square.
Oh, yes, sorry. Yes, it has to be an even polynomial, right? So as you can see, again we land this, whenever this happens, you will land up with an even or odd polynomial because you are forming the polynomial from one row. So coefficients will be missing anyway. The interesting thing about this DPDS is that the roots of this DPDS actually reflect the root, become the root of the original polynomial also. So 4 s cube plus 6s plus
Last term will be only 2, not 2s square.
yes. So plus 0. So this will become, I'll have a new polynomial which will be 4, 6, 0, and these other things will remain unaltered, and this 4 will become 2, and the 6 will become 3. So after we go about doing this, we are going to have 1 into 3 minus 3 into 2 by 2, so 3 by 2, which we can kind of inverse factor out and get 3, 4, 0, and then we'll have a 1 by 3 here, 0, 0, 0, and finally so now if I look at this, we can say the following things. First is, from S4 downwards, there is no sign change. It is positive, 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 positive. So these are, we are going to have all the roots on the imaginary axis. Now it's an 8th order
Sir?
polynomial. Yes, please.
So can't we say that from S5, like there's no sign change?
Yeah, agreed. What I was talking of is, when are we hitting the 0? We are actually getting the 0 at S cube, which means S4 is the culprit. It is this kind of a polynomial that is going to be getting factored out, and S to the power 4 polynomial is going to get factored out, and that is the culprit. And for that polynomial, let us see, this is actually, we are forming a polynomial starting from here. This is kind of reworking this part. this part, no sign change. So this means this is only possible if all the roots are on the imaginary axis. There is no flip-flop from the right hand plane to left hand plane for this part. Whereas this part, there are two sign changes, positive, negative, negative, positive, and we have a total of 8 roots. So 4 of the roots, we know they are the suspicious characters who lie on the imaginary axis. They are prone to making the system unstable, but they are not actually unstable as such. And before that, other part of this 8th order polynomial, the other factor, that means if I have an s to the power 4 polynomial like this, which is even, there will be another s to the power 4 polynomial, which will, however, not be even or odd. It will be a general quartic polynomial, and that polynomial will have 2 roots in the right hand plane and 2 roots in the negative left hand plane, because for 2 sign changes among 4, that is the only possibility. So we have So these are the kind of conclusions that we can draw, and of course this is going to be unstable because we have right half plane poles, and there are possibilities of the poles on the imaginary axis that can create problems for you. So here is something that you can try for yourself.
Sir, will the 4 purely imaginary roots be the roots of the P of S bar 4 plus 3?
This is coming, these 4 imaginary, purely imaginary, they are coming from this. Because there is no sign change for the s to the power 4, this polynomial, when you do you are actually effectively doing the route for this polynomial. And this shows no sign changes. So it means that it does not have any roots on the right hand plane. So it means you don't have the possibility of the, so 2 things are ruled out.
Sir, here like I and minus I are roots of both P of S and the original polynomial.
So in this possibility, no. This kind of pair cannot be there, because then you would have seen a sign change. You also don't see the possibility of quadrantal roots, because if you had that, again you would have seen sign changes.
Sir, so here the sign change means a change in the real value, like real part of the root.
Yeah, so obviously, I mean, like imaginary, we are seeing the sign change of the real part of the root. Yes, that is right. So if you don't have a right, if you don't see sign change, if you don't see a sign change here, then it means you are not going to have anything on the positive and something on the negative side. All must be having the same sign, and this is also not permitted. So since you can't have a sign change, then the 3 possibilities are there for an even polynomial. This is one possibility which is ruled out, because the route part corresponding to the even polynomial has no sign change. So this is ruled out. This is also ruled out because no sign change. So the only thing that remains is this possibility, and in this case it's actually this. This again,
So-
I mean, like that is, yes.
Sir, so here this PS is there. So that itself is not a factor of the original polynomial, isn't it?
Yeah, you have an s to the power 8 polynomial. So
Uh,
effectively it means you are factoring out, okay? You are factoring out and getting good roots.
so we are saying that this PS, that is s power 4 plus 3s square plus 2, that is a factor of the 8th order polynomial.
And the other part, it is actually, let me put it this way, this is equal to PS into a nicer polynomial, which is of the form S4 So this has all kinds of coefficients. Maybe they are, of course, it looks like they are some of these may be negative, but all the coefficients are present in this polynomial, unlike this.
So using this Ruth table, we can find out all roots of this thing accurately. That is not possible, right? Maybe one or two we can find.
You can't find out roots. You can find out the nature of roots, because again I'll repeat one thing. I mean, like, there are certain subjects. Let me digress a bit. We have talked about this a lot. Let's say mechanics of solids. Okay.
Yes,
So
sir, yes,
if
sir.
we had, it will look odd, but if we had, say, a way of directly measuring shear stress, our mechanics of solids textbooks would be half their size. In vibrations or dynamics, if we could add up rotations, just as we add up displacements in a vector form, large rotations, our dynamics textbooks will be half their size. Similarly, if you could find out all the roots of a polynomial, a nice clear-cut method, your controls textbooks would also become half, I mean, like, quarter of that size. It's this inability of us to fully find out, to have a complete, nice solution to finding out roots of polynomials has actually led to a lot of development in mathematics. That
Yes, sir,
inhibition.
yes, sir. That is understood. But then here we are accurately factorizing the polynomial, right?
We are not factorizing actually, because if we could factorize, then we could
Find out the roots, yeah.
find out the roots. If you, I have uploaded one document, you can check. I mean, like, that gives a simple proof of route. I could not find the other paper also that is there with me. There are two papers. Probably this paper will be referencing to the other one also. It's basically based on the fact that, see, if you have a polynomial of s to the power n, then right next to that, what will you have? S to the power n plus a n minus 1, s to the power n minus 1. Now what is a n minus 1? It is actually the sum of all the roots. And if you try to write down the route array for such a polynomial, you will see that right here in the second row itself, the first element will be the sum of the roots. So when will the sum of the, so if that is, so if there is a sign change, then it means your sum of the roots is negative. Let me try to illustrate, since you are asking this question. Okay. So now, even for those of you who have maybe slept through your first year maths class, you will still recall by virtue of quadratic equations that what is a n minus 1? This is sum of
Alpha I, like roots.
Till n equal to
Yes,
1.
all roots.
yes, I yeah. And
So
this
now,
is minus, right? Minus
for
a n
this,
minus 1.
S to the power n, Sn minus 1.
Yes, sir. That will be minus a n minus 1,
n
right?
minus 1, yeah.
So the first thing will be, this will be 1, and this will be something, anyway, forget about that, and this will be an minus 1. So this is going to be the sum of the roots. Now when is the sum of the roots negative?
When at least one of them is negative.
Has to be. So you see, it is
Yeah.
based on some
Sign
principle
change.
like this.
Hmm.
Not exactly factorization, but something close to that. They have this business of even and odd polynomials and use logic to work it out. The original proof was too complicated to be put in textbooks, but there are 2 papers in which they have tried to kind of simplify this thing and do this, and given a proof which is more understandable.
Sir, so when was this proved?
Oh my God! I mean, like, this
Old
is
or new, kind of?
Manjunath. It was, I think, I mean, this was probably in the 50s or 60s when this was first proved.
1950s, okay, okay.
Ah,
So
benefits
it's
of war.
complicated. Yeah.
It's the benefits of war. Most of the development in control systems took place in order to kill people.
World War II, okay, maybe, yeah.
Yes, communications, control systems, we developed all these fantastic things actually to kill people. Very sad, but that is the thing. So, there was a push, and then Cold War. So, all these theories developed, and this proof that I have given, that is came much later. The simpler version, that was in the 1980s or so. So
Yes, sir, yes.
you look at in the class materials, you'll find that I've uploaded that. So anyway, now we don't really have much time. I will just go through 2 things because these are necessary. We have just talked about how to figure out these roots thing, and now comes the application. Let us look at so I have a feedback control system. This is my CS. Input RS. Okay. So now what will be the transfer function for this? This will be DS is equal to GS by 1 plus GSHS. I'll have to skip those steps because of lack of time, but what you are going to get is S cube plus 18S square plus 77S plus K. So this K is kind of a gain. Okay. So now we will have to deal with forming the root of this. Our polynomial is so you form a route table. So now what do you have? This is surely positive. This is surely positive. Here is a question mark, here is a question mark. So you will have K. One is, like positive is kind of trivial, but if K is positive, and K is greater than 1386, while K is of course like 0. So this will be positive. In that case, K is greater than 1386, then this becomes negative, this is positive. So two sign changes. There is also another possibility. So in that case, so we actually have a row of zeros here. So my PS so this will be 36S. Okay. So we have no sign changes. So what we have, so when you are presented with this kind of a problem, you will normally be asked, I mean, like, this K will come because you are maybe putting in a gain here. Say you have your system, or just a simple feedback, and you wish to know whether even unity is bad. It could be that just a unity feedback could be bad enough for the system. So you may need to attenuate it, or maybe it is not good enough, you need to, and in that case you need to know how much gain can you give. So whenever you do this kind of a thing, you are going to get, say in this case, you are going to get GS by so you will have to figure out so you can figure out the range of K by, and also a trick question that you might often face is, okay, what is the value of K so that the system oscillates continuously? So this means you have to make a row 0. That is, you have to get some roots in the imaginary axis. So in that case, if you see a situation like this, this is your clue that okay, this is where I can make. You may get multiple such situations also. So you'll have to explore the possibilities depending on the nature of the problem. But these are basically the three things. One is how much, what is the lower bound of the gain, what is the upper bound of the gain, and what gain will cause the system to be marginally stable. When is this boundary of stability and instability, when is it going to get crossed? And when people want you to, I mean, like, think a little more, okay, so they won't just tell you that. They will say, for what value of, or they won't, people, or it won't even be called as a gain, okay? To make things complicated, in place of S plus 7, you will have S plus K1. And so for what value of K1 will you see oscillations in the system? Question can be posed like that. So more or less, there is one more point that I would like to cover. I'll require a couple of minutes more. See, there is another thing also that you can do with Routh, which is you have a polynomial. Okay, just something random. Now, what if you substitute replace S by S minus sigma. This is something that you can do, because actually right now we don't really use route that much. When we use, I mean, like modern control theory or state space, it's not used that much. But still there are benefits with route. So when you do this, what are you effectively doing? You are effectively shifting your origin. Okay? And what this will mean is, or I think it would be better if I actually so what actually is route telling us? It tells us how many routes are to the right of x is equal to 0. So in this case, it will tell us how many routes are to the right of s, or x is equal to minus 2. Okay? So that means these routes will have a positive part which is greater than minus 2, and hence
Sir, here the origin is shifted to 2, right? The origin is shifted to s equal to 2.
yeah. So you will have a decay constant tau is equal to 1 by 2, because basically if you have a root, say e to the power say 0.5, say 5 plus 4j, so how will it appear in the time domain? E to the power 5t plus 4jt, right? So that 5t part is the damping part. Here it is positive. And it will have a, and if it is negative, minus 5 plus 4j, so it will appear as e to the power minus 5t plus 4jt. So that 4 will give you the natural frequency and the minus 5 gives you an estimate of the damping. And what is the time constant? Time constant will be 1 by 5. So when you do this shifting, you can say how many roots are going to have cause a rate of decay faster than this particular value or slower than this particular value. So this is called a relative stability analysis. This is also sometimes people do using route. Okay, so this will kind of conclude today's lecture. Now I have a request for you. From you. Is it possible to shift Wednesday's class to Thursday evening? Same time? Hello?
Yes, sir. Like others, I don't know, but for me, it's fine.
Because my problem is actually on Wednesday I have as such a double lecture in the morning, and the following day again I have another lecture. So it will be better if I in the intervening time I can be better prepared for the class and also revise at least. As such, today itself I had a lecture in the morning. Tomorrow I won't, fortunately. So I don't want my two subjects to clash on the same day. So if you can figure out among yourselves whether it's possible to shift Wednesday's class, that will be good. Please let me know by tomorrow. Okay?
Sir, Thursday we have our classes in the afternoon. So if you can club the classes in the same time frame, like in the afternoon.
Afternoon, what classes?
Huh?
Thursday afternoon, what time do you want the classes to be?
Sir, maybe like
3 to 5?
2 to 3.
It will have to be 1.5 hour. Evening is not possible.
No, sir, possible. It is possible.
Sir, Thursday we have classes, sir. Computer integrated manufacturing.
Evening?
Yes, sir. 3 to 5 Thursday.
No, I was thinking of something like 8 to 9:30 or something like that. That is, in case of Wednesday, 8 to 9:30. Thursday, 8 to 9:30.
Like Thursday 8 to 9:30, I guess like the clash will be less. If somebody has an extra slot in which there's a class, then there will be a clash. This afternoon, etc. clashes or chances of clash is more for students. That's what.
Afternoon chances are more.
No, clash chances are more. Yeah, exactly. So it will be comfortable, I guess, Thursday 8 to 9:30 only.
Okay.
If anybody
anyway,
does not.
Discuss among yourselves and let's come to a conclusion tomorrow, because I would like to deliver something comfortably, not only for myself, and I should feel good about the lecture. The next thing is, okay, let me stop the recording. The next thing that I want you people to do is do a small assignment. Use Excel. Don't tell me that you don't have Excel. Use Excel and to form a spreadsheet which can do your route calculations. Try to incorporate within Excel these criteria. Understood? So first you use Excel.
So when do we submit the assignment then?
Maybe weekend.
Deadline.
Weekend. try to figure out using the Excel functions how you can first do it for the simple case, no non-zero, no zero stuff and all that, and then extend that logic so that when you encounter a zero, whether it is possible in Excel to get this done. Okay, so thank you all.